So how does the clock signal look like? It is just a pulse of train of like high and low pulses. Okay, so it looks like you always read the clock signal from left to right. So it is going from left to right, and this is considered as a logic 0, and this is considered as logic 1. Okay. Now this logic 0 may corresponds to a voltage level that could be 0 voltage, and this logic 1 corresponds to a high voltage level, let's say 5 volt. Okay, so these clock signals are generated by another circuitry, let's call it clock generator. So it will just keep fluctuating the voltage between 0 and 1 and 0 and 1, 0 and 5 volt, 0 and 5 volt. Okay. Now when the signal from, we are reading from left to right, when the signal from 0 goes to a high level, this is what we call a positive edge, which is taking the signal from 0 to higher. Okay, and this one, when the signal is going from high to low level, it is called the negative edge. Okay, and we have a certain period when the logic is high, and we have another certain period when the logic is low. It could be same, it could be different. Here in this example, you see the logic low period is greater than logic high period. It can be same, it can be different, but from one the duration between the one positive edge of clock with the next positive edge of clock is called the complete clock period. Okay, so this is just a term which you will be using in solving some problems related to performance. So this is what we call the one clock period or one clock cycle. So just like I told you, how many questions you complete in, let's say, 10 breath cycles, you don't know. But in computer, we say that we calculate the performance, how many cycles, how many clock period computer takes to execute a certain task. Let's say addition operation. Okay, so if I provide 2 plus 3, and what will be the result, and what result will be produced in how many number of clock cycles. Okay. Yep.
Did you say the clock period was the entire thing, or just the clock?
So clock period is from the positive edge to the next positive edge. It could be, you can also read it from the negative edge to the next negative edge. Okay, so the occurrence of the next same activity is considered as a clock period. Okay, so the clock signal oscillates between high and low values. The clock period is a time for the one full cycle, also called the clock cycle time. So whatever terminologies we are learning, you are going to apply that in the performance calculation or the performance evaluation of a computer. So this is also called the clock cycle time. It could be, for example, let's say we kept the high voltage for 5 nanoseconds, and let's say we kept the low voltage to 5 nanoseconds. So the total clock cycle time would be 5 plus 5, 10 nanoseconds. Okay. There is another term called the clock rate, which is also referred as frequency. It's a reciprocal of cycle time. And you have already studied frequency, or might already be familiar with the word frequency. So frequency is 1 over clock cycle. The clock cycle means like clock period. So if the clock cycle time is 1 nanosecond, you would say the clock rate is 1 gigahertz. So 1 nano means you will keep 1, and nano means 10 to the power minus 9. And when you solve it, you bring it up, 10 to the power 9 corresponds to the gig. Okay? And this is what, when you go for a computer shop or to buy a mobile phone, the processor specs tells you what is the speed of a computer, what is the speed of a processor, like 2.3 gigahertz processor. So gigahertz means 2.3 gigahertz means this at which clock speed it is running. Okay. Similarly, when you have the clock rate of 2 gigahertz, the clock cycle time would be 0.5 nanoseconds. You just simply divide it. Okay? Any question here?